Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on Venn diagrams and two-way tables. In particular, you need to be able to use these to calculate probabilities. So a question where either a Venn diagram or two-way table would be appropriate is this one here. Class of 32 students, 20 have blue eyes, 10 have blonde hair, 7 have neither. We're going to let A be the event student has blue eyes, B the event they have blonde hair. We're going to calculate this here, which says probability of not A and B. In other words, what's the probability a student selected at random does not have both blue eyes and blonde hair? So the reason that Venn diagrams and two-way tables would be useful here, we have a question involving information about two sets. So we've got the set of students with blue eyes, set of students with blonde hair. So whenever you have a probability question involving two sets, use Venn diagram or two-way table. It doesn't really matter which you use for this question. I'm actually going to draw both. So we're going to start off with a Venn diagram. So we've got two circles for our two sets. A, set of students with blue eyes, and B, the set of students with blonde hair. Now you might notice here that 20 blue eyes plus 10 with blonde hair plus 7 with neither actually equals 37. How is this possible when there are only 32 students? Well, the only way this is possible is if we've overcounted by 5. So that means there are 5 students who have both blue eyes and blonde hair. The only way we could add up to 37 is if I've included those 5 students in the 20 that have blue eyes, and I've included those 5 students again in the 10 that have blonde hair. So to finish off the Venn diagram, so if 20 have blue eyes, that means there's 20 in the A circle. I have 5 in there already, so there'll be 15 more. Similarly for the B circle, the blonde hair, I already have 5, so I need 5 more, and there'll be 7 outside the circle. Note 15 plus 5 plus 5 plus 7 does equal 32. So all 4 numbers in the Venn diagram should add up to the total number you had. Now, if I wanted to put that in a two-way table, I'm just going to draw up a table now. So the two ways correspond to the two sets. So two-way tables always look like this. So we can be an A or not A, and B or not B. Now, two-way tables also have a row and column for total, which Venn diagrams don't. So we just figured out that there are 5 that have both. So this is the number in both because it's in the A column, means they have blue eyes, and the B row means they have blonde hair. So this is A and not B, which are those 15 there. Similarly, B and not A, and then neither is there. So again, we can just add up totals here for the two-way table, and everything should add to 32. 20 plus 12, 10 plus 22 gives us 32, and we're done. So to answer the question is really simple. What's the probability of not being in A and B? So A and B, these 5 here. So the probability of not being in A and B, 15 plus 5 plus 7, 27 out of 32. Of course, I could have got the same answer from the two-way table. 15 plus 7 plus 5, 27 out of 32. So note the 4 numbers here in blue, these 4 numbers here are the same 4 numbers that appear in the Venn diagram. So let's now do a question that involves a three-way Venn diagram. So let's have a go at this question here. 80 Year 11 students surveyed as to whether they play soccer, cricket, or AFL. 28 play soccer, 31 AFL, 42 cricket. 9 play soccer and AFL, 10 play soccer and cricket, 6 play none, and 4 play all 3 of them. We're going to calculate this here. So this is saying the probability a student selected at random plays AFL or soccer and not cricket. So we're going to display this information to make this calculation easier. Now, we're given information about 3 sets, soccer, AFL, and cricket. So because we have 3 sets, a two-way table would not be appropriate here. Instead, we're going to draw a 3-way Venn diagram. I know you've seen these before. So we have 3 circles, 1 for each set, and they're overlapping. So we have our sets AFL, soccer, and cricket. Now, don't just go randomly putting in numbers like 28, 31, 42, like that. I mean, already these numbers add to way more than 80, so we'd be wrong. What I need to do is be a bit smarter about it. So let's start with the last piece of information. If 4 people played all 3 sports, 4 go here. This is where all 3 circles overlap. So I know 10 people play both soccer and cricket. So that means 10 people need to be in this region here. I already have 4, so I need 6 more. Similarly, if 9 people play both soccer and AFL, I need to have 9 in this region. I already have 4, so I add another 5 up here. Now, because 28 people play soccer, all these numbers have to add to 28. 6 plus 4 plus 5 is 15. I need another 13. Now there are 28 in the soccer circle. I'm also told that 6 people play none of these sports. So 6 people would go out here. So now I just need to find what goes in each of those 3 spaces. So let's just let the number that goes here be X. I don't know this because I wasn't told how many people play both AFL and cricket. But what I do know is that there are 42 people who play cricket. So I've already got 10 in the cricket circle. So these 2 numbers need to add to 32. So if this one's X, this will be 32 minus X. Similarly, I need to have 31 in the AFL circle. There are already 9 in the AFL circle, so these 2 numbers must add to 22. So this would be 22 minus X. So to find what X is, I'm going to use the fact that all the numbers inside the Venn diagram must add up to 80. So I can set up the equation. So there are 28 in the soccer circle and 6 outside the circles. When I add those plus the other 3 numbers, I need to have everything add up to 80. So 28 plus 6 plus 22 plus 32 gives me 88. Minus X plus X cancels out, and I've still got a minus X. So I've got 88 minus X equals 80. That means X is equal to 8. So that means that 8 people play both AFL and cricket. So I can put an 8 at their overlap here. So that means this number here is 32 minus 8, which is 24. And it means that this number that goes up here will be 22 minus 8, which is 14. So a quick check tells us there are 14, 8, plus 4, plus 5, 31 in the AFL circle. There are 42 in the cricket circle. All of these numbers add up to 80, so my Venn diagram is finished. That is the hard part done. So what is the probability that someone plays AFL or soccer and not cricket? So now we need to identify that region on the Venn diagram. So AFL or soccer are these regions here, inside this circle and this circle. But what we want to do is we want to only count the ones that are not in C. We want to exclude these 3 because these 3 numbers are in the C circle. So what's in A or S but not C? 14, 5, and 13. Everything in these 2 circles minus those that are also in the C circle. So it would be 14 plus 5 plus 13 over 80, which gives us 32 over 80, 2 over 5, or 0.4. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.